having here is all that you need to know for binomial expansion. Everything that you ought to know in binomial expansion is here. So how to state whether the condition where the expansion is valid, you are going to go through that. How to expand when this value that you have here is not 1, and also when the power is not a positive integer. If you are new to Proflan YouTube channel, consider subscribing so that in time we are going to upload another tutorial. So that in time we're going to upload another tutorial, you'll be notified. Let's dive in. This is all about how do you do binomial expansion and which is the best formula to use when you are given a particular question. Now, the first equation, when n is a positive integer, you are going to use the fraction, this particular formula that we have here. When n is a positive integer, for instance, if you are expanding 2 plus x raised to power 7, now our power n is a positive integer. So the best formula to use is this one. Now, I want to expand up to and including the term with x power 3. I want to expand this one up to the term and including the term which has what? X power 3. So, of course, we have this as 2 plus x raised to power 7 is equals to, we have said now, since our 7 is a positive integer, it's not a fraction, it's not a negative. So meaning that this is going to have finite terms, we are going to use this formula that we have here. So the first term becomes n combination 0, but our n in this case is actually 7, so we are going to say 7 combination 0. Then this term that we have here is 2, so we are going to say 2 power 7 times x power 0. Okay, so that when you add 7 plus 0, you get the same power, 7. The second term will be 7 combination 1, 2 raised to power 6. The power of 2 keep on decreasing as the power of x increases. So this now new power becomes 1. You see now 6 plus 1 will give us the power 7. Then we have the third term, which is going to be 7 combination 2. And then we have 2 power 5. And x now in this case is going to be x power 2. The third term will be plus 7 combination 3. This is the fourth term, right? First, second, third, and fourth term. And this is going to be 2 power 4 x power 3. So the series continue that way. But we can now try and solve this. We are going to simplify this by putting our information in the calculator, and the way we are going to put it is that we are going to say 7 combination 0, 7 combination 0 is going to give us 1. You can see 1, 7 combination 0 is 1, then times 2 power 7, 2 power 7, and the answer now becomes 128. The first term here becomes 128 because x power 0 will be 1, then plus. The second term that we're going to do is going to be 7 combination 1. The answer we get times 2 raised to power 6. If you work it out, you are going to get 448. So 448 here, x, 448x, plus next term is 7 combination 2, which is multiplied to 7 combination 2 in this case, and the answer we get times 2 raised to power 5 times x squared, and that translates to 672 x squared. Then we have the third term, the fourth term rather, we have the fourth term, which is having x cubed, is going to be raised to power 7 combination 3, 2 raised to power 4, and the final answer becomes 560, and this 560 now is having x power 3. So this is the expansion that we were supposed to get in this particular question. So that is how you are supposed to use this formula here in order to work out. Now you can be given a question like, now expand up to including the term with x squared, including the term with x squared. So let me just give you a different kind of question, a question which is having 1 plus 5x raised to power 6. Let me use power 6. Now this one, you see, it's the first term is 1, so it's best you use this particular formula that we are having here, which means that our x that we have here is taken by this number 5x. So meaning, in order to write this, we are going to say that the first term will be 1. The first term will be 1 plus 6 combination 1, 5x raised to power 1. 6, this is a 1 plus 6 combination 1. Our x is this term which is having 5x here, so meaning is raised to power 1. Then plus the next term will be n combination 2, so it will be 6 combination 2, then 5x raised to power 2. Now you see, with this term that we have here, we are going to have x squared at this point, so we can decide and leave our expansion at that point. Then we need to go and simplify. This will be 1 plus 6 combination 1, then we're going to multiply that, because you can see here we are having a 5. 6 combination 1, we get the answer, then times 5, because there was a 5 there. And if you multiply that, you are going to get 30. So we are going to have 30x plus 6 combination 2. The answer we get times 5 squared, because this bracket is having a power here too, so it will be 25 times 25, and that's going to translate 375x squared. 375x squared. So we have managed to expand this to the term that was expected. Now we have the third formula. When n is not a positive integer, then we are going to have this series is going to be infinite. it's going to be infinite, it's going to be endless, it will continue forever. But when you have positive integer, you are going to have finite terms. But this one now, when you have non-positive integer and fractions, you can be able to use this kind of formula, and in that case this formula is going to be valid in a given region, which is x less than 1. Now let us do a question so that you can be able to see exactly how we're going to use this formula here. And that is going to be, let me just say, expand. I'm going to give you two questions so that you see different scenarios which you can be able to apply here. Expand 1 plus 3x squared raised to power 1 over 3 up to the term with x up to the term including x raised to power 6. We are going to perform our expansion until we arrive at a point where we have x raised to power 6. Now, the formula state is 1 plus x, but our n here, in this case, our n is equals to 1 over 3, right? And our x is equals to, our x now, in this case, when we are going to substitute x, what are we going to put here? We are going to put 3x squared. This is what we shall be putting as our value of x. Now, to do this, we are going to say 1 plus 3x squared raised to power 1 over 3 is going to be, the first term is going to be 1. The first term is going to be 1. And this is going to be 1 plus the second term will be nx. Is going to be n, and our n, you can see we said is 1 over 3. So it will be 1 over 3, and our x is represented by this guy that is seated here, and this is going to be 3x squared. So that is it. Then plus the second term, this the third term now, because we have the first term, the second term, now we're moving to the third term. The third term is going to be n into n minus 1. So we're going to say that is going to be n, but our n is 1 over 3. So let me just, can I write it here? Yeah, let me see whether it can fit here. So I can say n, but our n is 1 over 3, n minus 1. So I'm going to say 1 over 3, again 1 over 3 minus 1 over 2 factorial, then x power 2, x power 2, is 2 factorial, x power 2, and our x is 3x squared, then squared. So there, I can see now at this point of time, I cannot say that this is x to the power of 6. I need to move to the next term because this squared times 2 is going to be 4. So I've not arrived at the term they told me. So I need one extra term. And that next term, how are we going to find it? Is going to be n 1 over 3, n minus 1, 1 over 3 minus 1, again n 1 over 3 minus 2 over 3 factorial, then 3x squared raised to power 3. Now we are almost home and dry. Now we need to simplify each of the expansion that we have. The first one becomes 1. The first term is 1. The second term will be a third times 3 is going to be x squared. The next one we are going to have, let me just put this in a calculator so that we don't make a mistake. We are going to say this is going to be open the bracket 1 over 3. I'll expect you do that also, and then close the bracket, then open bracket again, 1 over 3 minus 1, close the bracket, then times, what is this? This is power 2. Yes, power 2. So this power 2 is going to affect this x squared, and also is going to affect this 3. So to my binomial expansion here, I'm going to multiply 3 squared, because there's this square here, and this 3 will be affected by that power. So I have to put it that way. So if I simplify that, I'm going to get my answer equals to -2, then divide by 2 factorial, and the answer becomes -1. -1, which means that this term translates to minus x power 4. X power 4. The whole of this term will becomes x power 4. And then I'm going to work out the next term here. Let's see the next term what it will be. I'll have to put 1 over 3 times 1 over 3 minus 1, again times 1 over 3 minus 2, close the bracket, this one, then this 3 raised to power 3 should be there, times 3 raised to power 3. I get the answer as 10, and then I divide by 3 factorial, and my answer becomes 5 over 3 positive, 5 over 3. This would be plus 5 over 3x power 6. So this is the expansion now using this particular formula. Now, a question like this here, you'll be asked, where is this expansion valid? Where is this expansion valid? How are you supposed to answer a question like that? You are asked, where is this expansion valid? This expansion that we are talking about, where is it valid? So this is the next question that we're going to answer. Now, if you are told to state where the expansion is valid, you are going to pick this term that you are having here. Just pick the term the way it is. And you are going to say 3x squared modulus less than 1. Validity, valid at. The expansion is valid at. Okay? So we can now factor out 3 and remain with x squared less than 1. Divide by 3, divide by 3. This is going to reduce to x squared less than 1 over 3. Then now we are going to find the square root both sides. If you find square root of this, you get x. You find the square root of this, you get 1 over root 3. And this is going to be x now is less than 1 over root 3, right? And this can be written as, let me just I see you cannot be able to see where I've written that. So which means that if you find the square root for this part here and square root for this part, we are going to have our expansion valid, and we shall have x less than 1 over root 3, right? And this can be written as, this as well can be written as, this space enough. X is less than 1 over root 3 greater than -1 over root 3. So you can as well write it this way, right? So basically the expansion is valid in these particular regions. Of course, if you rationalize the denominator, it will be something else. This can also be given as x greater than -root 3 over 3 less than root 3 over 3. The same thing, just the same thing written differently. So you need to know how to make use of all these formulas when you are given. Now, And also we are going to state where our expansion is valid. Now, so what I was saying is that the way the expansion is given, we cannot be able to apply this formula because we don't have one at this particular point. We have to find a way in which we can treat this so that we can have one here, then apply this formula that we have at this point. So to do that, let me write the, we can decide and divide by 4 on this term, divide by 4 on this term. So we take the 4 out and say -1/2 should have the same power as this one. Then inside we say it's 1 minus 3/4 x squared raised to power -1/2. You can take this 4 out. This 4 you can take it out, and then you divide this 4 you are taking out in the second term. But when you have taken it out, remember to put the power, the original power, the way it was. Right? Are we together? You take the number that is here out, you take it out, you take it out, you divide 4, divide by 4 is 1. 3x squared divided by 4 is 3x squared over 4. So this is the expansion now we are going to work out. And what is 4 raised to power -1/2 equivalent to? 4 raised to power -1/2 is equivalent to a half. Is equivalent to half. Yes. So meaning this term that we have here is half. So we can say this is going to be 1/2 into bracket 1 minus 3/4 x squared raised to power 1/2 negative. Now this is where we are going to apply the binomial expansion up to the term including x raised to power 6. Let me just write it here. So I'm going to write when I'll be working it out. Now I'm going to say my expression is going to become 1/2 into bracket 1 minus 3/4 x squared raised to power -1/2. Now, whenever we are performing this binomial expansion, we are going to identify what our n. Our n is equals to -1/2, and our x that we shall be substituting, our x is the one that is equivalent to -3/4 x squared. This is what we shall be replacing anywhere we have x. Anywhere we have x. So the first term of this expansion is going to be 1/2 into bracket 1 minus 3/4 x raised to power 2 -1/2. The first term will be 1. So I'll have to write my half the way it was here, because whenever we were expanding, when we were expanding this, it's not having a half, but I'm having this half here. So I'm going to ensure that I include it outside before the expansion. So when I'm expanding this, I'll write the first term to be 1. But this half is because we are having this half at this point. Then plus. My next term is nx. My n is -1/2. -1/2. I put it in bracket like that. And my x is this term that we are having here, -3/4 x squared. Right? So I believe I'm done with this part here, so I can be able to make use of that space. And if you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. Just a way of supporting the channel to grow. Kindly subscribe, like this video, and also share it to your friends. Take a moment to like, leave a comment down below. Okay, so now this is the second term, which is n x. My n is negative 1 over 2, my x is negative 3 over 4 x squared. Then the next term here, it will be n into bracket n minus 1 over 2 factorial x squared. So my next term will be my n, so that will be minus 1 over 2, n minus 1, so it will be minus 1 over 2 minus 1 over 2 factorial, then x squared, but my x is negative 3 over 4 x squared, then now I square that. Yeah, so if I can see this term is not up to x power 6, so we need to move to the next term here, and the next term is going to be like this. The next term, when this sequence actually continues, so the next term will be n into n minus 1 into n. Now once we have done n minus 1, the next one will be n minus 2, 3 factorial, then x power 3. So that will be the next term on this. So my n is negative 1 over 2, negative 1 over 2 minus 1, negative 1 over 2. I think I'm writing big fonts, and my space is quite limited, so I need to reduce a little bit. Minus 1 over 2, minus 1 over 2 minus 1, minus 1 over 2 minus 2 over 3 factorial, then my x cubed, but my x is negative 3 over 4 x squared, so I'm going to say minus 3 over 4 x squared raised to power what? Raised to power what? Which power should be this? This power should be power 3. Now, let us try to simplify 1 over 2. The first term will be 1. This is negative 1 over 2 times negative 3 over 4. Now, this becomes positive 3 over 8 x squared. Now, this one, I have to use my calculator. Now, we have negative 1 over 2. We are going to say this is going to be negative 1 over 2. We are working on this. So how are we going to write it? Open the bracket, negative 1 over 2. We cannot afford messing this question here. Then open the bracket again, negative 1 over 2 minus 1, close the bracket. Yeah, you see we are having here negative 3 over 4, because this number is going to be raised to power 2. Yeah, raised to power 2. So we are going to say again, once we have entered this, we're going to say times negative 3 over 4, but that one is also affected by this power 2. Power 2. The answer we get, we are going to divide by 2 factorial, and that translates to 27 over 128. 27 over 128. So plus 27 over 128, but x squared raised to power 2 is going to be x power 4. Then we need to work out this term also. Similarly, we are going to ensure that we are following each of the steps properly. This one is going to be 1 over 2 times 1 over 2 minus 1 times 1 over 2 minus 2. If you work it out, we are going to get 405 over 104 over 512. Then we divide by 3 factorial. And that coefficient becomes 135 over 1024. So this becomes plus 135 over 1024. But since this is x squared raised to power 3, and then this will be x power 6. So we have worked our answer up to the term including x power 6. Of course, this is not going to be our answer now in this case, because we're going to multiply by a half. This one now is going to reduce to what? This one reduces to the first term. It will be a half times 1 to be 1 over 2. This one is going to be plus 3 over 16 x squared. This one is going to be what? Plus 27 over 256 x power 4, then plus 135 over 2048 x power 6. And then the last question that we are supposed to state where the expansion is valid. Where is this expansion valid? We can see now our expansion is valid where x is less than 1. But what was our value of x, and which part are we going to use? Are we going to use this part? This part? No, we're not going to use this. We are going to use this part of the equation here. So the term we are going to use is this term we are having at this point. Because even if it's a negative, modulus means you are going to take positive value. Even if we are having the negative here, right? Even if we have this negative at this point, we are going to take this as positive, because modulus means you are taking positive values. So this is going to be 3 over 4x squared. 3 over 4x squared should be less than 1. Less than 1. Now to simplify, so meaning this, that what are we can take the constant out, 3 over 4x squared less than 1, and then multiply by 4 both sides, and again divide by 3 both sides. So we are going to have x squared less than 4 over 3. Now you see, we cannot leave it this way, because we can be able to find square root for this, square root for that. Then we shall have this as x modulus less than 2 over root 3. Yeah. So if you put into your calculator, this can be the same as, also it can also be the same as x less than 2 root 3 over 3, because this is actually rationalized. So if you rationalize this, it becomes this. But this equation now, this condition can be written as greater than negative 2 root 3 over 3 less than 2 root 3 over 3 as our final answer. So the expansion is valid in this region. If you have found value from this particular video, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. See you in the next tutorial.